Okay, guys, carrying on. We're gonna finish chapter 1. Sorry, guys, the previous one. I know it definitely took longer than I intended at 30 minutes, but it is what it is. We gotta get these things done. So let's get going. Number 8, talking about whether the function is odd or even or neither. Remember, for a function to be odd, that just means that f of negative x is a negative of f of x. And for it to be even, that means f of negative x is exactly f of x. So in this case, we're going to check f of negative x. Original f of x was 2 over x, right? It's going to be 2 over negative x, which is exactly a negative of 2 over x. So which case does this fall into? That falls into this category right here, right? I've got the f of negative x is the negative of f of x, which makes it odd. So it's an odd function. And if it's an odd function, that means it has symmetry over the origin. What does symmetry over the origin means? That means if you were to take your graph, rotate it 180 degrees across the center point of the origin, then it would land right back on top of itself. And just a real quick sketch, 2 over x. 2 over x has the general same shape as 1 over x. Kind of has this sort of shape. In fact, if you were to kind of just scale these guys by half, then you have the exact same picture. And if you think about, rotating this piece, oops. Let's see, maybe I can do this thing as a whole. So for us to think about rotating this guy 180 degrees, well, it's actually going kind of well. Then you see how it would land right back on top of itself, yeah? Well, that was actually kind of cool. And I didn't know I could do that. Okay, so yeah, that's what it is. Number 8, done. Moving right along then to number 9. Okay, number 9. Find the average rate of change. Okay, average rate of change, really that's just, it's very similar to the slope. It's what is your f of the end result minus f of the starting result divided by the change in the x's. This is really just how much did your y values change over how much did your x values change, which is the slope, right? And in this particular case, the function is the square root of x plus 1. So to start with, we're going to find out what is f of 9. That would be the square root of 9 plus 1, which is square root of 9 is 3, plus 1 is 4. And what is f of 1? That would be the square root of 1 plus 1. Square root of 1 is just 1, plus 1 is 2. And so we check, yeah, that's the y2 minus y1. Basically, it's 4 minus 2 over x2 minus x1, which is 9 minus 1. 4 minus 2 is 2. 9 minus 1 is 8. So I got 2 8s, which reduces to 1/4 as your average rate of change. Average rate of change is just 1/4. Yeah, so simple. Average rate of change, just take f of the two numbers, subtract them over the two numbers themselves subtracted. Okay, that's number 9. Now for number 10. Okay, number 10 says find the inverse of that thing. Fx equals x minus 1 over x plus 2. Where x cannot be equal to negative 2. Why can't x equal to negative 2? And we all say it's because then your denominator would be undefined, right? You'd be divided by 0. It's kind of like Blue's Clues, yeah? Just ask a question. Okay, so to find the inverse, first step, remember, just rewrite with y instead. And then second step is to swap y's and x's, right? That's kind of the critical thing about finding inverses. That's what I think about. When I think about how do you find an inverse, basically you swap y's and x's and then solve for y. So this is like that. Right now I'm going to solve for y. How do I solve for y? Well, I want this guy out of the denominator, so multiply both sides by y plus 2. And on the right side is going to cancel, but on the left side it's going to be x times y plus 2. Okay, and then now what can I do? Well, I'm going to try to just gather all my y's. So first thing would be to distribute this thing to separate it, right? So I'm going to get xy plus 2x. And then equals y minus 1. Now I'm going to move the y's over to the left side. So I got xy minus y. Meanwhile, I'm going to move this 2x to the right side. So it's going to be equal to negative 2x minus 1 like that. Yeah. Okay, and then now it's kind of one of those critical steps we've seen before, but we're going to factor out the y here. So it's going to be x minus 1, right? Y times x is xy, and then y times negative 1 is negative y, so that makes sense. And then finally divide by the x minus 1. So I get y equal to negative 2x minus 1 over x minus 1. And that essentially is your inverse function. One final thing is to just label it as the inverse function. So f inverse of x is what I just had over there a moment ago. And that is inverse function. Make sure you add that x cannot be equal to positive 1, because then I'd be dividing by 0. Okay, so that's part A done. We found the inverse. And then next is to sketch that and its inverse in the same plane. Okay, so this was the original function. Let's start by sketching that guy. Okay, so I'm focused right now on sketching the original function first. This thing right here. And looking at the thing, first thing I notice is it's got an asymptote right here. It's x equal to negative 2, right? Because that's what would make the denominator 0. So let's do that in purple, negative 2. Asymptote. Okay, now let's think about end behavior. What happens as x goes to infinity? Well, this guy is going to be basically they're basically the same, right? They're both growing the same pace. They're both same power of x. It's going to be like x getting really big over x getting really big, and it's going to head towards positive 1. Think about like a million divided by a million. Million minus 1 over a million plus 2 is roughly 1, right? Okay, and then what else happens here? Let's think about when this thing is 0. This thing is 0 when the top is 1, right? When the top is 1, and when x is 1, then you're at 0. So that'd be 1 comma 0 is over here. Yeah. And when is y going to be 0? Y is going to be 0. I'm sorry. I think I wrote that backwards. When x is 1, y is 0. That's what I said, yeah? Yeah. Okay, what about when is, what happens if x is 0? So if x is 0, it's going to be 0 minus 1, which is negative 1, over 0 plus 2, which is 2. So a negative 1 over 2 is negative half. So when x is 0, I'm at negative a half. That's right here. Okay, that kind of tells me what's going to happen, right? I'm going to, I should approach this asymptote. Should hit those 2 points and then approach that asymptote. So that's the general rough picture. Okay, and then my intuition tells me the other part of the graph is going to be up here, but let's just check, make sure. Let's plug in negative 3, see where we're at. If I plug in negative 3, it's going to be negative 3 minus 1 over negative 3 plus 2, which is negative 4 over negative 1, which is positive 4. So 1, 2, 3, 4. So negative 3, I'm at positive 4 over here, right? And that puts me right where I expect it to be. Now I'm going to follow the line of the asymptotes, something like that. And I got my general picture. Okay, now I'm going to make my second picture. I'm going to draw the inverse now. Let's do that in green. This guy here. And first thing I notice is I got a vertical asymptote at positive 1. So kind of analogous to the horizontal asymptote at positive 1, right? But this time it's a vertical asymptote. So you notice that those are actually just flipped of each other, right? And what should my horizontal asymptote be? Well, last time I had a vertical asymptote at negative 2. This time, look, as x goes to infinity, the things that went out is this negative 2x and the x, which is negative 2 over 1. So that's going to be negative 2 as a horizontal asymptote. So again, kind of like analogous to the vertical asymptote of negative 2, right? Okay, now let's figure out our other major points. So if x is 0, this is going to be 0 minus 1, which is negative 1, over 0 minus 1, which is negative 1. Negative 1 over negative 1 is positive 1. So when x is 0, I'm at positive 1 right there. I said I wanted to do this in green, so let's do green. Okay, what about what's going to make y equal to 0? What's going to make y equal to 0 is when this top is 0. That's going to happen when x is negative 1/2. So when x is negative 1/2, y is 0. So I'm right there. Yeah. Okay, remember, I'm following the green asymptotes this time. So that should look something like this. Right? And you see that this picture right here is the reflection, this guy, the reflection of this guy across the line y equal to x. Let me draw y equal to x for you just so you can see it for reference. Okay, y equal to x is this orange line right here. So you see how this, the reflection of that guy over that, and that's what should happen with inverses, right? Which means I should expect the other piece to be down, the reflection of that should be down here. Let's just double check now. I'm going to plug in the point. What's a good point here? 1, 2. How about 2? That'll determine if I'm there like I expect it to be. So I plug in 2. That's going to be negative 2 times. Let's plug it in down here. Negative 2 times 2 minus 1 over 2 minus 1, which is negative 4 minus 1 is negative 5 over 2 minus 1, which is 1. So negative 5. So I got the point 2, negative 5. 1, 2, 1, 2, 3, 4, 5 down here. And I'm right where I expect to be. Yeah, so I'm right here like that. So you see that this portion and this portion are reflections of each other over this orange line, y equal to x. Okay, so finally we finished sketching both, and looks like we were correct about the oh, I shouldn't erase that actually. We're correct about the inverse, yeah? So I'm gonna erase this work in between so we can answer that last question. Now, of course, if you're doing this question, you have more space, you just continue on. I'm just trying to keep things all within view, so that's why I'm clearing out this space in the middle. Okay, this is part C, yeah? Determine domain and range of both functions. I think, I'm gonna have to cut this video after this one because this is getting long, so. Domain and range, so let's do f of x domain. I already knew it. It's just, I'm gonna write like this, just say x cannot be negative 2, right? That's where I had the one asymptote. Right now I'm looking at the purple picture, right? Negative 2 was my asymptote right there. And otherwise, I can be anything. What about the range? Range, the only thing I don't hit is this positive one, right? So basically y cannot be positive 1. Or if you rather think of it as intervals negative infinity to 1, union 1 to infinity. Yeah? Okay. What about the inverse? So now let's look at the inverse. So the domain, we saw, this is the inverse down here, right? X cannot be positive 1. Well, that makes sense because remember, inverses, they have the opposite ranges and domains, right? And what about the range? Well, the only thing I don't hit is this negative 2 here. So it's y cannot be negative 2. Or again, if you want to think of these as intervals, negative infinity to negative 2, union negative 2 to infinity. Domain would have been negative infinity to 1, union 1 to infinity. And also I could have done this guy, same thing. Negative infinity to negative 2, union negative 2 to infinity. Just the same thing with in interval notation. All right, this is getting long, so I'm going to cut this video.